The Junos OS uses the Session VRF to provide stateful inspection and session-based security. The Junos OS forwards traffic between the two routing instances over logical tunnel interfaces. Because the routing tables of the two routing instances are separated, the Junos OS shares the routing information. The Junos OS shares the routing information between them by means of either a static or dynamic routing protocol. All traffic going in or out of the Session VRF participates in security zones and must pass through security policies to be allowed through. The configuration requires a selective packet-based firewall filter to place the traffic into packet mode. The operator configures the filter inbound on the logical tunnel LT000 Unit 1 interface. The Junos OS applies the filter as traffic ingresses the packet VRF. In-session maintenance. When a packet enters the system and does not match any existing sessions, the Junos OS creates a new session based on routing and security policy information. Once this new session is created, the software puts it into a session hash table for further packet matching and processing. Depending on the protocol and service, TCP or UDP, the session is programmed with a default timeout. The default TCP timeout is 30 minutes, and the UDP default timeout is 1 minute. Session cleanup. If no traffic matches the session during the service timeout, the Junos OS ages out the session and frees it to a common resource pool for later reuse. In-session runtime changes propagation. The flow module is responsible for propagating any runtime changes that happen during the lifetime of the session. This propagation allows new packets that match the session to forward using up-to-date information. Routing runtime changes always propagate into the session. Security policy runtime changes might propagate into the session in progress based on the corresponding security policy and zone configuration. We discuss this topic more thoroughly in later chapters. In-management session characteristics. Sessions are created based on routing and other classification information to store information and allocate resources for a flow. Sessions have characteristics, some of which you can change, such as when they are terminated. For example, you might want to ensure that a session table is never entirely full to protect against an attacker's attempt to flood the table, and thereby prevent legitimate users from starting sessions. You can configure the Junos OS to aggressively age out sessions based on how full the session table is by specifying the following options under the Edit, Security, Flow, Aging configuration hierarchy. Early age out. Specify the timeout value in seconds in which sessions age out once the high watermark value is met. High watermark. Specify a percentage of how full the session table must be. Low watermark. Specify the percentage at which the SRX device disables the early age out function and returns to the default age out time for the session. TCP security. The Junos OS provides a mechanism for disabling security checks on TCP packets to ensure interoperability with hosts and devices with faulty TCP implementations. Applying the following commands under the Edit Security TCP-Sessions configuration hierarchy can increase the throughput of the SRX device at the cost of security. Employing the No-Sync-Check command tells the Junos OS that it does not need to look at the TCP SYN packet for session creation. The No-Sequence-Check command disables TCP sequence checking validation. SYN checking and sequence checking are enabled by default, and the previous command disabled TCP SYN checks and TCP sequence checks on all TCP sessions, hence reducing security. This might be required in a scenario with customers or with applications that do not correctly work with these standards. However, you can disable the TCP SYN checking and TCP sequence checking globally, and then specify these mechanisms on a per-policy basis. So let's review. What type of packet processing do traditional routers provide? Well, traditionally, routers process packets on a per-packet basis. What type of packet processing do traditional firewalls provide? Well, traditionally, firewalls process packets based on stateful flows. What are the two main differences between the Junos OS that runs the Junos security platform and the traditional Junos OS? The Junos OS that runs on the security platform uses session-based packet forwarding and by default does not allow any traffic to pass, whereas the traditional Junos OS uses packet-based forwarding and by default allows all traffic to pass. How is the first packet of a session handled differently from subsequent packets of the same session? The first packet of the session is subject to first path packet processing. Alright, that's it for this section.